Good morning. Today we're going to talk about the implementing using Hadoop and MapReduce concept. And I am Warissara with my friends Manop, Saharat, and Thanaphat.
Hello. I'll be explaining the concept about big data and MapReduce. So let's start with big data. What is big data and how do we define it? Well, we can define big data as a collection of large data sets that is impractical to analyze or use with a traditional computing system. The traditional computing system may take too long or is inefficient to use to analyze. These big data may be generated by sites such as Google or Facebook or even YouTube. And these data could have a high velocity and complexity to them. So here we introduce MapReduce. MapReduce is a method in programming that is used to help analyze big data. This MapReduce process can help to work in parallel, and we will explain that further how MapReduce coincides with the Hadoop file system. This MapReduce helps to analyze huge volumes of complex data, as suggested in the previous slide, any data from big sites such as Google or Facebook. So let's compare the MapReduce versus just the normal computing system. The traditional systems make use of a central server to store and process data, and this method is not suitable for to process big data. This may create bottlenecking in the data pipeline as the data is traversed through the system. And this problem was seen by researchers at Google at the time, and they have proposed a solution called MapReduce. So MapReduce will be explained in greater detail how it eliminates bottlenecking and how it is better than the traditional system. Okay, so here we show the MapReduce in conjunction with the Hadoop file system, so the HDFS in the yellow box. So in this, we can see that there are blocks of the file system in Hadoop, and the big data is distributed in these blocks. And the mapping function and the reducing function is then responsible to take the data from each block and convert them into a more useful and more readable form of data. And this works with the HDFS so that not only does the MapReduce work to fasten the process, but also uses parallel computing. Now, this one is a great example of how MapReduce works. In this example, it is a word count process, which is also what we did as an implementation in our project. Assuming that we have a data set of the following words like deer, bear, river, car, and we want to count the words, how many words there are. So as you can see in the input box, there are just the raw data set. The second process would be to split the data set. In this case, the data is split using the lines of data, so three different lines. These lines are then processed into the third step, which is the mapping step. So in this mapping step, it only creates a key value pair of which words occur how many times. After this one is a quite important step, which is the shuffling and the sorting. So from all the output of the mapping function, the words are then shuffled and sorted into their respective groups. And the last process is to reduce them. So after sorting them, the reducer, all it does is just sums the value and outputs as a final result. So that's the overview of how a MapReduce process works from just mapping and reducing to the final result.
Okay, so let's get started using Hadoop from installation part.
Next, we gonna talk about the installation process and how to setting the Hadoop single node cluster up. And the first one, we need to creating the user. It is recommended to create a separate user for the Hadoop to isolate your Hadoop file and the system from the the unique file. And the next one, we need to set up the SSH and the key generations. The SSH setup is required to do the different operations on a cluster, such as starting, a stopping, and the distributed daemon shield operations. We need to install the Java, and we decide to use the Java versions 8 for compatible with the Hadoop versions. We need to create the Hadoop directory for storing the program and the Hadoop log. And you can follow our instructions from this slide to run the command. And next, we need to create the directory for the name node and the data node. And we need to download the Hadoop, and you can select your Hadoop versions from the Epic Software Foundation Cup. And we need to, after we extract the Hadoop file, we need to move it to the user local to make all user can access it. And the next part, we need to configuring the Hadoop environment. Next. And after you done the installations, okay, next for the testing Hadoop, we can testing by start the name node and the data node by using the following command: start DFS or the distributed file system. As you can see, we're gonna start the name nodes at the localhost and the data nodes and the secondary name node. And the last one, we need to start the yarn to start the resource managers and the node managers. And the result, you should see, you should use the JPS command to see the result of your node. And you should have the resource managers name node, the secondary name node, data node, and the node manager.
Okay, that's all of the Hadoop installation process. And this is our problem and dataset we use. The problem is the word count example that we will implement using Hadoop. And the dataset we use is the William Shakespeare e-text that we can find from the internet. And the size of the dataset is 929,000 with 396 words. The character is around 5 million characters, and the document length is around 5 million. So we'll see like how can we implement Hadoop in the word count example. And this is our source code, and my friends will explain about the programming.
In this example is the Hadoop MapReduce program. This code is written in Java programming language. And in this figure that you can see is a import a library from Hadoop and Java. This is the map function. The map or mappers job is to process the input data. Generally, the input data is in form of file or directory and is stored in the Hadoop file system. The input file is passed in the mapper function line by line. The mapper processes the data and creates several small chunks of data. The reducer's job is to process the data that come from the mapper. After processing, it produces a new set of output which will be stored in the Hadoop file system or HDFS.
I will show you a result of our implementing as a video. Thank you for your attention.